Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic voltage to current converter and current to voltage converter. So this comes under the applications of operational amplifier. So here is the outline for this video. So as an introduction, we can see why do we need these type of converters. So whenever we are measuring any physical quantity, the sensors that connected will always provide the signal in terms of current, but the A to D converters for any data processing need the signal to be in the form of voltage. So in such cases, we need to convert this current to obtained current to voltage signal. Similar way, many actuators uh, require current signal, but it is not happened in many cases. Control systems provide only voltage signal. So such conditions leads to the design of voltage to current and current to voltage converters. And coming to the basics of operational amplifier, so these voltage to current and current to voltage converters are designed with the help of the operational amplifier because of the basic properties like infinite open loop gain, infinite input impedance and zero output impedance, which provides the better performance. Coming to the topic voltage to current converter. A voltage to current converter accepts an input signal as a voltage signal and gives the output of a current output as a current value. So this can be represented with the equation I out will be equal to S into V in. This V in represents the input voltage and S represents the sensitivity or gain of the voltage to current converter. So this can be further viewed with the help of the circuit diagram and it will be explained further. Here if we see the circuit diagram, we are having the connecting the voltage signal to the non-inverting terminal of the operational amplifier and output is obtained as the current signal. So how this is possible, we can see it now. These circuits, according to the visual concept, so the voltage connected to the non-inverting terminal will be equal to the voltage across the inverting terminal. So when we are applying the nodal equation, that is KCL equation at the inverting terminal of the this circuit, so we will be obtaining Vi by R1 minus I naught equal to 0. So from this equation we will obtain I naught equal to Vi by R1. So which shows the output current will always be directly proportional to the input voltage. So this is how we are obtaining the current from the voltage input signal. Similarly, current to voltage converter. So here we are connecting the current to the inverting terminal. We are connecting the current input to the inverting terminal and the non-inverting terminal will be grounded. So here the feedback path is mentioned with the resistor RF where the current across the node in the inverting terminal is I minus. So this is the case. So in this case, when we are applying KCL at the node, we will get the output V out will be equal to IP, that is current across the input path, and it is multiplied with RF, resistance across the feedback path. So V out will be equal to IP into RF. So this equation provides the current to voltage converter equation. So if we are giving the input to the operational amplifier as a current signal and its equivalent output is obtained as the voltage from the output path of the operational amplifier. So these both are very similar and its applications are mentioned here based on the converter types. So first voltage to current converters. So here the current loops, it is mainly used in voltage to current converters are used in current loops, LED drivers and electrochemical sensors. So mainly in the sensor circuits, LED driver circuits, we will be using this converters. And coming to the current to voltage converters, we are having photodiode amplifiers, electrometers and DAC output conditioning. DAC represents the digital to analog converter. So we in this video we have seen about the introduction to the operational amplifier and what is the purpose of such converters like voltage to current and current to voltage converters, and what is the operation of voltage to current converter, and what is the final equation, and how the current in the input signal of the operational amplifier is converted as the voltage signal, so that is represents the in current to voltage converter, and finally the applications we have seen. So that's all about the today's topic, and here we are in the assessment part. So what is the purpose of the V2I converter? So convert voltage to current. So which sensor commonly requires an I2V converter? Photodiode is the right answer. So current loop typically uses a voltage to current converter, which we have seen in the applications. Okay, thank you all for joining this video. We can join in the next video.